Hello guys, welcome to the course National Test Abhyas questions or the NTA mock test questions. Now what are these NTA mock test questions? Well, I hope you all know that NTA, this is the National Testing Agency which is holding the JEE mains and the NEET examination. All right, so this agency, this has put up an app that is called as the National Test Abhyas, which is free for all students. You do not have to pay for it, so you should all surely download it on your mobile phones. Okay, so now this National Test Abhyas, there are several mock tests for the JEE students, several mock tests for the NEET students, and what we have done is that we have scanned all these question papers and separated the questions chapter wise. And then we have built up a theory which is going to be helpful for a quick revision of your concepts related to the questions which have been asked in these mock tests. And then we have chosen a few questions so that you can see those questions. And with that, we will be giving you some theory so that you can even revise your concept. So essentially, it is going to be a quick revision of your concept at the same time looking at the questions which are going to be asked in these NTA mock tests. All right, so today the topic that we will be discussing is going to be hydrogen and the compounds of hydrogen, obviously the complete chapter hydrogen of class 11th. So here today I will be giving you 20 very important questions which we found from these NTA mock tests and which help us make you understand what are the important topics which are being asked from the question. This is going to be the questions which will help us quickly revise the important concepts from the chapter. So I hope you are going to really enjoy it. It is going to be very helpful for your upcoming examination and you're going to really score very well. I am Dr. Ritu Johar, your educator from the channel H2O, the A to Z of chemistry, and I hope you're going to enjoy your learning with me. So let us begin our learning. But before that, one very important thing. The important thing is going to be that please do read your NCERT textbooks very well, especially for inorganic and organic chemistry. That is going to be the key to your success. And the next thing is, there is one more important thing that I want to tell you people, that when we are discussing these questions, please first of all listen to the question. I will be reading the complete question. Then when I have finished the question, just pause, think about what is going to be your choice. Okay, and then look at the solution. I will be simultaneously giving you the solution. If some theory is required for that, I will be doing that also. But first of all, try attempting and choosing your own choice and then look at the solution. That way it is going to be very helpful session for you people. So now let us begin. So let us look at question number 1. Question number 1 says that hydrogen has 3 isotopes A, B and C. If the number of neutrons in A, B and C respectively are X, Y and Z, then you have to tell the sum of X plus Y and Z. And this is going to be a very easy question, but it is going to be very important also. Why it is important is if you look at the previous year JEE mains questions, you will be finding a question in JEE mains 2019 as well as in 2020 related to the isotopes of hydrogen. Okay, so therefore this is important for you people and it is easy. So well, let us quickly revise the concept of isotopes of hydrogen. Before that, I would just want you to look at your NCERT textbook simultaneously over here so that you know exactly what are the topics that we are covering in these NTA mock test questions. But along with that, whatever we are leaving behind also, you just go and give a reading to that as well. For example, before the isotopes of hydrogen, in the NCERT textbook, it has been discussed about the position of hydrogen in the periodic table, the properties which are going to be similar to the alkali metals as well as to the halogens. So please do have a reading of that, and along with that there are certain points about the occurrence of hydrogen. So just go and read that, and then we are talking about the isotopes of hydrogen. So let us quickly look at the isotopes of hydrogen. So first of all, let us look at what do we mean by isotopes quickly. So isotopes, they are the atoms of the same element which are having the same atomic number but different mass number. And when we say the isotopes of hydrogen, we will be having 3 isotopes of hydrogen. Number 1 is going to be protium, where we will be having 1 proton in the nucleus and 1 electron outside orbiting around the nucleus. So here there is no neutron present. And in fact, you have to remember this very importantly, that there is only one element in the whole of the periodic table which does not have any neutron. Rest all the elements will be having a neutron, and that is going to be hydrogen. And what isotope of hydrogen? It will be protium. Okay, so this is the most predominant form, and it constitutes 99.984% of the sample of natural hydrogen. The next we have is deuterium. In deuterium, we will be having one proton and one neutron in the nucleus and one electron outside. So you can see over here that the number of protons is the same, so the atomic number is the same. And when the atomic number is going to be the same, the number of electrons is also going to be the same in the neutral atom, but the number of neutrons is varying, and hence the mass number is going to vary. So deuterium, this is H21, or it is simply written as D, and this is also called as heavy hydrogen. Heavy because it is having a greater mass. So it occurs mostly in the form of HD. So you all know that hydrogen, this exists as a diatomic gas. So protium molecule will be containing of H2, two atoms of hydrogen, whereas deuterium molecule is going to be consisting generally in the form HD. There is going to be one atom of protium and one atom of deuterium in the molecule. Okay, and then it is going to be constituting 0.0156% of terrestrial hydrogen, and this can be separated by physical methods. And the next we have is tritium. So tritium, this is going to be one proton and two neutrons. So it is going to be having the mass number 3, and the atomic number is going to remain 1 for all of them. And this is the radioactive form of hydrogen which emits beta particles, and you can see the reaction also for that. So we have tritium, which is going to break down into helium 3 2, and it is going to be emitting a beta particle along with that. So there is one atom of tritium per 10 to the power 18 atoms of protium in the natural abundance. So this is rarely found. Deuterium is going to be the next one, and protium, this is the maximum concentration. All right. Now, very importantly, what you have to remember relating to these isotopes of hydrogen is that all the isotopes, they have similar chemical properties, but well, they are differing in the rates of the reaction. And why do they differ in the rate of the reaction? This has been asked previously in some examination. It is because of the difference in the enthalpy of bond dissociation. The enthalpy of bond dissociation is going to be less for hydrogen and greater for deuterium. Okay, and if it is going to be greater for deuterium, this means we have to give it more energy to break the bonds in the hydrogen, in the deuterium molecule, you can say. Okay, so when the bond dissociation enthalpy is going to be more, the energy that has to be supplied to break the bonds is going to be more. It is going to be less reactive. Right, so protium will be more reactive than deuterium, and in fact, if you look at the data, we have protium which reacts with chlorine 13.4 times faster than that of deuterium. Okay, so this is going to be important, but there is going to be obviously a difference in the physical properties of the isotopes. Why is it going to be? Because of their difference in the mass. Okay, so the melting points, the boiling points, density, so these are the factors which are going to be different for the three isotopes. So now I think you people can quickly answer the question. We have put quickly a table for this also, and the number of protons is going to be remaining the same for all the three. The number of electrons is also going to remain the same. The only difference is going to be the number of neutrons. So 0, 1 and 2. And in this question, what you have been asked is the sum of all three. So it is going to be equal to 0 plus 1 plus 2. So this will be equal to 3. Okay, so I hope you reached the correct answer yourself as well. But we have revised the isotopes now, so that you just asked any question related to that, you can quickly answer it. So the next question is that which one of the following pairs of substances on reaction will not evolve hydrogen gas? Iron and steam, iron and H2SO4 aqueous, copper and HCl aqueous, sodium and ethyl alcohol. So this question is related to the preparation of hydrogen. So I would request you all, what all reactions are given in the NCERT textbook related to the preparation of hydrogen. Please do remember them very well. Okay, so now you can just pause the lecture over here and first of all choose your option, and then we are going to be seeing the correct answer. So if you've done that, let us quickly look at the solution. So well, first of all, we have the reaction of iron with steam. So iron, when it is going to reacting with steam, it is going to be producing Fe3O4, that is ferroso-ferric iron, and along with that hydrogen is going to be evolved. The next reaction we have is for iron and H2SO4. So it is going to be again producing ferrous sulfate, and along with that hydrogen will be what? But when it is going to be copper and HCl, there is no reaction going to take place, and whereas sodium and ethyl alcohol, well, again, sodium is going to be displacing hydrogen from the alcohol, and what we will be getting is C2H5ONA, and along with that hydrogen will be evolved. So the correct answer to this question is going to be C, that copper and dilute HCl, they will not be reacting and they will not be evolving hydrogen. Now, to attempt this question, what you have to remember is the activity series. So all the elements which are going to be above hydrogen in the activity series, these are the elements which can evolve hydrogen when they are going to be reacting with water, or when they are going to be reacting with dilute mineral acids. But all the elements which are below hydrogen in the activity series, well, they cannot evolve hydrogen when reacting with water or dilute mineral acids. Okay, so this is one thing that you have to remember. Another thing that you can remember is that the elements which are going to be above in the reactivity series, they are going to be very easily evolving hydrogen. So potassium and sodium, they can even react with cold water and evolve hydrogen, and when they will be doing that, well, they will be producing their corresponding hydroxide. For example, when it will be Na, and along with that cold water, the reaction is going to be producing NaOH, and along with that hydrogen will be evolved, and the reaction with potassium will be producing KOH, and along with that hydrogen will be evolved, and this will be a very explosive reaction. When we move on to the reaction with calcium, calcium plus water will be producing calcium hydroxide and hydrogen, but the reaction will be slow. The next, when we have magnesium, we have aluminium. So these are the elements which can react with hot water, and again they will be producing their corresponding oxide now. Okay, so when it is cold water, they will be producing hydroxide, and when it is going to be hot water, they will be producing now the oxide. Along with that, hydrogen will be what? And when we will be moving on to the elements which are just above hydrogen in the activity series, like we have iron, we have tin, we have lead. So these are the elements which will be reacting only with steam to evolve hydrogen, and the elements which are going to be below, they will not be evolving hydrogen when they will be reacting with water. And similar is going to be the reaction that we will be seeing with the dilute mineral acids also. Okay, so this is something that is very important from the preparation that you have to remember. And in case you want to have a complete understanding of all the preparatory reactions of hydrogen, we have already put up a detailed playlist on hydrogen. Okay, so all the lectures in detail, there are 13 lectures there, and lecture number 4 in my playlist on hydrogen, you can just simply check out all the preparatory reactions for hydrogen. Okay, so that will be very helpful for you people. So next we have is question number 3. So question number 3 says that in the reaction zinc plus NaNO3 plus NaOH forming sodium zincate plus A plus water, the sum of the stoichiometric coefficients of Zn and A in the balanced reaction with simple integer coefficient is going to be, and this is again a numeric type of question. Okay, so you have to choose your option and then look at the solution. So, well, the explanation, let us look at first of all the reactions that we have over here. First reaction we have, this is going to be two reactions that we will be taking place. First, we have a reaction of zinc plus NaOH. This is forming sodium zincate, Na2ZnO2, and along with that hydrogen will be evolved in this reaction. Okay, so this is a reaction where you have to remember very importantly that zinc is, this is an amphoteric element. An amphoteric element, this can react with dilute mineral acids as well as with alkalis to evolve hydrogen. Again, this is one of the preparatory reactions, and zinc reaction with dilute mineral acids is the reaction that we use for the laboratory preparation of hydrogen. So zinc can react with both alkali as well as acid to evolve hydrogen. That is one thing that you have to remember. All the amphoteric elements can behave just like zinc in their evolving of hydrogen. The next thing that you have to remember in this question. Okay, and now the product that is formed over here. So now the next thing is that we have NaNO3. So NaNO3, when this will be reacting with hydrogen, this will be producing more of NaOH. Along with that, ammonia gas will be produced, and along with that, water will be produced. So if you look at the overall reaction we will be having is zinc plus NaNO3 plus NaOH will be giving us sodium zincate, ammonia and water. So A over here is going to be ammonia. Now this one reaction, the reaction of NaNO3 with hydrogen, you please do write it down in your NCERT textbook because this is not given over there. Okay, so there is no reaction given related to the reaction of sodium nitrate and hydrogen giving us ammonia gas. So this is something, please do note it down. This has been asked in the mock test question, so the reaction becomes important for you people. Okay. All right, so we have ammonia which is being produced. So now you just have to simply write the stoichiometric coefficients, adding them up for zinc and for ammonia. So zinc we have 4 and ammonia is 1. So 4 plus 1 is going to be 5. So the correct answer over here is going to be 5. Okay. Now the next question that we have is that which two sets of reactants best represent the amphoteric character of zinc hydroxide? Zinc hydroxide plus OH ion, zinc hydroxide plus water, zinc hydroxide plus H ion, zinc hydroxide plus ammonia. And you have asked that whether 1 and 2 sets they are correct, 1 and 3, 2 and 4, or 2 and 3 they are correct. So you can just pause and first of all choose your answer and then look at the solution. Well, the correct answer to this question is going to be B. We have 1 and 3 to be correct, which means the zinc hydroxide when it will be reacting with OH ions and zinc hydroxide when it will be H ions. This is 1 which represents the amphoteric character of zinc hydroxide. So simply here what you are tested is what do you mean by amphoteric compounds. So amphoteric compounds are going to be those compounds which can react both with acid as well as base. So zinc is an amphoteric element and zinc hydroxide is an amphoteric compound. And here one thing more which I can suggest you people is to make a list of all the amphoteric elements and a list of all the amphoteric oxides and hydroxides that we have, because that is very frequently asked in the examination. Okay. So next we move on to question number 5. Question number 5 says that when a substance reacts with water, it produces a combustible gas B and a solution of substance C in water. When another substance D this reacts with a solution of C, it also produces the same gas B on warming, but D can produce B on reaction with dilute H2SO4 at room temperature. A imparts a deep golden yellow color to a smokeless flame of Bunsen burner. A, B, C, D, they are respectively, and the choices they are given to you. So again, you can pause the lecture over here. First of all, try your question answer, and then we will be looking at the solution. Now, how we are going to proceed with this is by reading carefully each and every line. And when you're going to read up to the end, you will be getting the clue to the question. So the question at the end says that A imparts a deep golden yellow color to the smokeless flame of the Bunsen burner. So here you have to remember that all the metals, they impart a characteristic color. No two colors they are going to be the same. That is going to be very important for the identification of these metals which can impart a color to the flame. And therefore you have to learn all the alkali metal and the alkaline earth metals which can impart color to the flame and what is going to be the color. So that is going to be very, very important. And once you have learned that, you will remember that it will be golden yellow color imparted by sodium. So sodium is only in one choice. So obviously the correct answer will be A. Okay, potassium will be imparting a violet and calcium will be imparting a brick red color to the flame. So we will be getting the answer with just this part of the question, but well, we will be just checking up the rest of the reactions also. So we are having a substance A, that is sodium, which reacts with water to produce a combustible gas B and a solution of substance C in water. So it is going to be reaction of sodium with water, which will be giving us NaOH and hydrogen. So A is going to be sodium, substance C is going to be NaOH, and the combustible gas is going to be B. Okay, now the solution of C, that is NaOH, this can react with another substance to produce same hydrogen, and D, that is again which will be produced. This can also react with B on reaction with the dilute H2SO4. So what this means is that this D can react with both acid as well as base to evolve hydrogen, and therefore it has to be an alkali, an amphoteric element. Okay, so we, for example, take over here zinc. Zinc, when it is going to react with NaOH, will be giving a sodium zincate along with that hydrogen, and it is also going to be reacting with H2SO4 to give us zinc sulfate and along with that hydrogen. So D is going to be zinc. So you can just check over here all the choices, they are fitting into place with the option A being the correct answer. So now let us look at 6. Question number 6 says, how many of the following are saline hydrides? And they are given methane, which is given sodium hydride, HF, chromium hydride, palladium hydride, lithium, calcium, titanium hydride. So these are the hydrides, and you have to choose which one is going to be a saline hydride. And I would like to show you one more similar question over here. Question number 7. Total number of elements which do not form hydrides from all these elements. Okay, so we have two questions related to the hydrides. In fact, I have not put up all the questions from the NTA mock test. There are going to be at least 3-4 more questions on the hydrides which were in the NTA mock test. So these hydrides again is going to be a topic which you should read very carefully, and it is very easy also. A quick revision I'm going to give you over here for the key points. So we have 3 types of hydrides. We have ionic hydrides, ionic compounds, covalent hydrides, covalent compounds, and interstitial hydrides, where we will be having essentially metals into the interstitial spaces hydrogen will be fitting in. Okay, so the other name for ionic hydride is going to be saline or salt-like hydrides. These are compounds of hydrogen with the S block elements. For example, lithium hydride, sodium hydride, potassium, rubidium hydride, cesium hydride, strontium hydride, barium hydride, and all these hydrides, they are ionic compounds, but please do remember that lithium hydride, beryllium hydride, and magnesium hydride, they will be having a significant covalent character. Okay, next we have is covalent hydrides. So these are going to be molecular hydrides. Most of the p block elements, when they will be combining with hydrogen, they will be covalent compounds. So for example, we have methane, we have ammonia, we have water, then we have HF. So all of these, they are covalent hydrides. The next we have is interstitial hydrides. So they are called as metallic hydrides. So they are just fitting into the metal lattices in between spaces. These are going to be the compounds of hydrogen with the D and the F block elements. And here in the examples, very interestingly, very quick way to find out is going to be that here hydrogen is not going to be a whole number combination with the metal. These are non-stoichiometric hydrides. So one more name you can put in over here, that these are non-stoichiometric hydrides. So you are seeing over here hydrogen as a fractional number, 2.87, 2.55, and so on. Okay, so these are the interstitial hydrides, the hydrides of hydrogen with the D and the F block elements. One more important thing related to the hydrides that you have to remember is that the metals of group number 7, 8, and 9, they do not form any hydrides. So this particular gap in the periodic table is called as the hydride gap. In group number 6, only chromium can form hydrides. So I just want you to look at the periodic table for that. So in the periodic table, when you look at group number 6, chromium is the only element that will be forming hydrides. Molybdenum, tungsten, they will not be forming hydrides. Okay, then we have manganese, technetium, rhenium, then next iron, ruthenium, osmium, cobalt, rhodium and iridium. These are the elements which do not form hydrides. So this is very important for you people to remember these. So in question number 6, where we were supposed to find out the saline hydrides, the number of hydrides that comes is going to be 3. We have sodium hydride, lithium hydride and calcium hydride to be saline hydrides. Next we have is the total number of elements which do not form hydrides. So these are the elements of group number 6, 7, 8 and 9. And from group number 6, you have to remember that chromium is the one which forms hydrides. Okay, so that will be important. So when you are going to choose the correct answer, well, molybdenum, then we have iron, then we have cobalt, then we have ruthenium and tungsten. These are the elements which will not be forming hydrides at all. So the correct answer is going to be 5. Now, before we finish up this topic of hydrides, there is one more important thing that I want you to remember, that is the classification of covalent hydrides, because there were questions even related to this classification of covalent hydrides in the NTA mock test, which I have not put it as one of the questions. Okay, so that would have been just a revision. So let us quickly just do the topic. So we have the covalent hydrides being classified into 3 types: electron deficient hydrides, electron precise hydrides and electron rich hydrides. In the electron deficient hydrides, we will be having the central atom with incomplete octet. Okay, so that is why it is deficient. Then precise, where the central atom will be having a complete octet, and electron rich, they will be having excess electrons present as lone pairs. So the electron deficient hydrides, they are going to be the hydrides of group number 13. For example, we have BH3, aluminium hydride, gallium hydride. So all of these, they are electron deficient hydrides, and because they are electron deficient, therefore they act as Lewis acids. Then we have the electron precise hydrides. So these are having the central atom with a complete octet. They are going to be the hydrides of group number 14. For example, we have methane, we have SiH4, we have GeH4, and all of them, they will be having all 4 covalent bonds. Therefore will be having a tetrahedral geometry. Next, in the electron rich hydrides, we are going to be seeing the hydrides of group number 15, 16 and 17, where we will be having the central atom with lone pair of electrons. For example, ammonia, it is having 1 lone pair of electron. We have H2O, it will be having 2 lone pair of electrons, and then we will be having HF with 3 lone pair of electrons, and all of them, they will be acting as Lewis bases. So again, this is going to be very, very important for you people to remember related to your problem solving. So question number 8 now is that a metal M produces a gas N on reaction with alkalis like NaOH and KOH. The same gas is produced when the metal reacts with dilute sulfuric acid. So now I hope now you very well understand that we have a metal M which is reacting with alkali as well as a acid, and it is producing a gas. So you should be able to now with so many questions practice quickly able to identify that it is going to be what type of element. Okay, now this gas N reacts with another toxic substance P to form methanol at high temperature and pressure, and also reacts with metals like Q to form electrovalent hydrides. So that is why I put this question after hydrides. M, N, P and Q, they are going to be respectively, and the choices they are given. So now first part of the question I've already told you, also given you a clue also. Just try now your question yourself. So let me tell you how I thought of this question. First of all, we have metal M, which is producing gas N on reaction with alkali as well as with dilute sulfuric acid. And the gas N is going to be hydrogen, because you can see it is going to be same in all the 4 choices. Okay, so this means that it has to be an amphoteric element, because it has to react both with acid as well as base. So it is either going to be zinc or it is going to be aluminium. Now the next is going to be that the gas N, that is hydrogen, it will be reacting with another toxic gas P to form methanol. Okay, so it has to be toxic. If you check about the toxicity, carbon monoxide is also going to be toxic and H2S is also going to be toxic. But when it is going to be carbon monoxide reacting with hydrogen to give us methanol, and it will not be H2S, because methanol is CH3OH, and where will carbon come in the reaction of H2S and hydrogen? Okay, so this is one thing that you will come to know the answer. And it was also very clear that N reacts with metals like Q to form electrovalent hydride. So electrovalent hydride is going to be formed by an S block element, and sodium is an S block element and boron is a P block element. Okay, so from here also you can get the correct option to be A choice. But let us quickly look at all the reactions. We have first of all zinc to be the amphoteric element, which will be reacting with NaOH to produce sodium, zincate and hydrogen. Very repeatedly you have seen this reaction in so many questions. And then we have zinc reacting with dilute sulfuric acid to produce zinc sulfate and hydrogen. And now hydrogen is going to react with carbon monoxide in presence of zinc oxide and chromic oxide at a very high temperature and pressure to produce methanol. This reaction is very, very important. First of all, carbon monoxide and hydrogen, this is called as water gas. And because it is used in the production of methanol, and again it is used in the production of many organic compounds further, therefore this is also called as syngas. Okay, so this is again mentioned in the preparatory reactions of hydrogen. There it is going to be very, very important that you people see all those reactions as well. As far as this reaction is concerned, this has been asked even in the previous year JEE examination question. So very, very important reaction. And the next we have is sodium reacting with hydrogen to form sodium hydride, which is going to be an electrovalent hydride or ionic hydride, a salt-like hydride. Okay, so the correct option is going to be A choice. So moving on to question number 9, and we will be starting here with the discussion on water, some important concepts related to water which have been asked in the NTA mock test questions. So which one of the following statements about water is false? Ice formed by heavy water sinks in normal water. Water oxidizes to oxygen during photosynthesis. Water can act as both acid as well as base. And there is extensive intramolecular hydrogen bonding present in the condensed phase. So you can choose your option first. So the correct option to this question is going to be T choice. Why? Let us look at all the choices one by one. So the first one we have is that ice formed by heavy water. This sinks in normal water because heavy water, this is going to have a greater mass and a greater density than normal water. And anything which is going to be heavier is going to sink down. Okay, so heavy water, this has greater density than normal water, so therefore it is going to sink down. Okay, the next one we have is water oxidizes to oxygen during photosynthesis. So carbon dioxide plus water is going to form C6H12O6, that is carbohydrate, and along with that an oxygen is going to be evolved. So this is the reaction of photosynthesis. So here what you can see is that oxygen in water is going to be in the -2 oxidation state, and here it is in the elemental state, so it is going to be 0. So -2 to 0 oxidation state, this is an increase in oxidation number, and therefore it is going to be oxidation reaction. Okay, so water is going to get oxidized to oxygen, so this is going to be correct. The next we have is that water, this is going to be amphiprotic. It can act as both acid as well as bases. It will going to be depending upon which compound it will be reacting. If it will be reacting with a stronger acid than itself, it will be acting as a base, and if it is going to be reacting with a base which is stronger than itself, it will be reacting as an acid. Okay, and then we have there is great extensive intramolecular hydrogen bonding. No, this is going to be incorrect, because in case of hydrogen bonding taking place in water, we will be seeing that in the condensed phase, that is in the solid state, we will be having extensive intermolecular hydrogen bonding. So intra means it is just in the molecule, whereas intermolecule is in amongst the various molecules. So let me just show you the various structures for the intermolecular hydrogen bonding taking place in the liquid as well as in the solid state. So here you can see now water hydrogen bonding taking place in the liquid state and as well as in the solid state. So in the ice you can see that there is a proper network of hydrogen bonding taking place, whereas in the liquid state it is just random hydrogen bonding that will be taking place. Okay, so extensive intermolecular hydrogen bonding amongst molecules, a lot of hydrogen bonding. And one more important point that you have to remember is that both ice and water, they have hydrogen bonding, but the density of ice is less than water because of this open cage like structure of ice. Okay. All right, now question number 10. Before I read it also, I'll tell you just one very important thing, that question number 10, question number 11 and 12, all the three questions, they are related to the hardness of water. So please do understand the importance of the topic. Read it thoroughly very well. I will be revising with you briefly, but that is going to be a brief discussion only. And in case you want to have a detailed understanding of each every small little concept, so just go to my detailed course on hydrogen, watch lecture number 9 and lecture number 10. They are related to the hardness of water. Okay, so lecture number 9, we will be talking about what is hard water, what is the hardness causing salts, and what is the difference between hard and soft water, what are the different types of hardness and how we are removing them, each and everything in detail. And the second lecture, that is lecture number 10, that will be on the numericals based on the hardness of water. All competitive questions in the previous year examinations have also been covered in that lecture, so that will be very helpful to you people. So now let us look at the questions which are there in the mock test. So question number 10 says that when zeolite, that is hydrated sodium silicate, this is treated with hard water, sodium ions, they are exchanged with H ions, calcium ions, sulfate ions, magnesium ions. It is going to be 2 4 1 3 4 1 4 and 1 2. So you have to choose wisely your option. If you understand what is hard water, well, this question is going to be very easy one. Okay, so if you people have attempted it, well, the correct answer to this question is going to be A choice. The ions with which sodium is going to be exchanged are going to be calcium ions and magnesium ions, and these are the cations which are responsible for the hardness of water. It is always going to be calcium and magnesium salts which will be responsible for the hardness of water. And sodium ion, this is also positive ion. So positive ion is going to be always exchanged with a positive ion. So Na positive ions from zeolite will be exchanged with calcium ions and magnesium ions. But it is quickly revised about what all we can very quickly do about the hardness of water. So quickly revising the concept of the hardness of water. First of all, the two types of water based upon hardness. We have soft water and hard water. Soft water is going to be the one which produces lather with soap easily, whereas hard water does not produce lather with soap. Soft water does not contain the dissolved calcium and magnesium salts, whereas hard water, this contains calcium and magnesium salts. Then soft water, the cleaning quality of the soap is not going to be affected, whereas in case of hard water, the cleaning quality is going to be affected, and along with that, soap is going to be wasted a lot in case of the hard water cleaning. Okay, therefore soft water is going to be very good for laundry, industrial boilers, when hard water, this is not going to be suitable for laundry as well as for the boilers. So laundry, you understand that a lot of soap is going to be wasted, so we're not going to use it, and even the cleaning quality is going to be affected, so we do not use it for laundry. Whereas in boilers, what is going to be happening is when we are going to heat water in a boiler, there is going to be the formation of calcium and magnesium carbonates which are going to get deposited onto the bottom and onto the walls of the boilers, and that is also going to cause a decrease in the efficiency of the boilers. So that is why we do not use it for boilers as well. Okay, so now what are the hardness causing salts? So the hardness causing salts, they are going to be the bicarbonates, the sulfates, the chlorides of calcium and magnesium. So this is going to be very, very important for you. Even this a simple thing, and it has been asked so many times in the examination, and still the students get it incorrect. So please do remember this very well. So we have two types of hardness of water now. One is going to be temporary hardness and the other is going to be permanent hardness. So the temporary hardness is because of the bicarbonates of calcium and magnesium, whereas the permanent hardness is because of the chlorides and the sulfates of calcium and magnesium. Temporary hardness is because of bicarbonates, so we also call it as carbonate hardness, and permanent hardness we also call it as non-carbonate hardness of water. Then we have different ways to remove this hardness. So temporary hardness, we can remove it by simply boiling, or we can use the Clark's method where we add slaked lime, that is calcium hydroxide, to the water, and the temporary hardness is going to be removed. Okay, whereas in permanent hardness we have many important ways in which we can remove it, and you should have an understanding of all of these. Okay, it is very, very important. So we have permanent hardness being removed by adding washing soda, that is sodium carbonate. We can use it by remove it by exchange of ions, that is the ion exchange method or the zeolite or the permuted method. Here the cations will be exchanged. Then we have the Kalgan's method. Again, the cations are going to be exchanged over here. And the synthetic resin method, this is going to be the best method because this removes both the cations and the anions which are responsible for hardness. Okay, so that is the advantage of using the synthetic resin method. Now, little bit more into the details of these methods. Well, I'm going to put up the next question. So question number 11 that says match column 1 with column 2 and mark the appropriate choice. So column number 1 we have Clark's method, Kalgan's method, ion exchange method, synthetic resin method, and in column number 2 we have the compounds which are used for the removal of hardness in these methods, and you have to match. So if you know about these, only then you will be able to do that. And this is very important for you to remember all these compounds that we are using over here. Okay, so if you have learned it, so just quickly attempt your answer and then we will be just seeing the solution. So well, now the correct answer to this question is going to be D choice. D choice is, I'll be putting up the correct box for you people. So according to the D choice, and we have the columns. We have Clark's method first of all, where we will be using calcium hydroxide slaked lime for the removal of temporary hardness, and the rest of the three they are used for permanent hardness removal. Okay, so in Kalgan's method what we use is sodium hexametaphosphate, that is Na6P6O18. Then in the ion exchange method we use hydrated sodium aluminium silicate, the formula which is going to be NaAlSiO4, and in the synthetic resin method we use RSO3H. So this is going to be an organic compound that we use. So resins, they are chiefly long organic compounds that we are using, and here also we will be seeing an exchange of the cations as well as the anions for the salts which are causing hardness. Okay, so please do read them in detail in case you want to watch the lecture, have a thorough understanding. That would be my lecture number 9 from the detailed hydrogen playlist. Okay, so the correct answer is going to be D choice, and you should know all these names very well. Moving on to question number 12 now. So question number 12 is that RH2, that is the ion exchange resin, this can replace calcium ions in hard water as RH2 calcium ions. So this is removing these H ions, it is becoming RCa and 2H positive. If 1 liter of hard water after passing through RH2 has pH 3, then the hardness of calcium in ppm is going to be 10, 40, 100 and 20 ppm. So this is one of the numericals for the hardness of water, and more questions I've already told you, they are in my detailed playlist on hydrogen, lecture number 10. Okay, so you can see the previous year questions also there. So choose your answer and then I'll tell you the solution also. So the correct answer to this question is going to be D choice, that is 20 ppm. So let us quickly see the solution to the question. So first of all, what is given to us is that the pH of the H ions is 3. So this means H ion concentration is going to be 10 power minus 3 molar, or it is going to be 10 power minus 3 moles per liter. Okay. Now For every 2 H ions, what is going to be required is only 1 calcium ion. So what is going to be the concentration of calcium ions? It will be 10 power minus 3 divided by 2. That will be 5 into 10 power minus 4 moles per liter, or you can write it as 5 into 10 power minus 1 moles of calcium ions per 10 power 3 liters. Okay, and if I make it as ml, it is going to be 10 power 6 ml. Okay, and you know the density is going to be 1 gram per centimeter cube. So we can convert 10 power 6 ml into 10 power 6 grams. Okay, so we have now 5 into 10 power minus 1 into 40 grams of calcium ions per 10 power 6 grams of water. Okay, so 10 power 3 liters, that means 10 power 6 ml, that means 10 power 6 grams of water, because the density is 1 gram per centimeter cube and 1 centimeter cube is going to be equal to 1 ml. I hope all these concepts are very clear to you people. Okay, so we will be therefore having the ppm or the hardness of water to be equal to 20 ppm. Okay, so this is what we have. So you can watch more lectures, more questions in my lecture number 10 from hydrogen playlist. Now the next question is that peroxide ion, this is present in MgO, CaO, Li2O or BaO2. So how are you going to do it? Well, I will be talking about that a bit later. But first of all, this is the peroxide ion. So I hope you understand that we are onto the last topic of our discussion from hydrogen. And there are 8 questions on the topic of hydrogen peroxide. Okay, so these are going to be 8 questions from 20 questions. So you just understand the importance of the topic. And these are not the only questions that were in the mock test. I've just chosen a few of them so that I can give you an understanding what is being asked in the examination. So please be very thorough with your study of hydrogen peroxide. So here we have first of all the peroxide ion. So you should have an understanding what do we mean by the peroxide ion. So very simply here you have just to find out the oxidation state of oxygen, because as far as the alkali metals they are concerned, they will be always in the +1 oxidation state, and the alkaline earth metals they will be always in the +2 oxidation state. It is going to be only oxygen that is going to be varying. I just take one example to just show you the different types of oxides that we have, the oxide, the peroxide and the superoxide, so that you just remember them very well. Okay, so we have first of all taken the example of here of the various oxides in relation to potassium. Okay, so we have K2O. If I have K2O, it is going to be potassium oxide. Here the oxidation state of oxygen is going to be 2 minus 2. So this is the -2 oxidation state, because potassium will be +1. So +1 into 2 will be +2. Oxygen will be -2. Okay, so oxidation state of oxygen is going to be -2. The next we have is K2O2. So this is potassium peroxide. How do we come to know about this? Well, first we have potassium 2 in +1 oxidation state. So +1 into 2 is going to be +2. Okay, so the two oxygens will be having an oxidation state of -2. So O2 2 minus. When it is O2 2 minus, well, on each oxygen the oxidation state will be -1. So in the oxide it will be always -2 oxidation state. In the peroxide it will be always -1 oxidation state. And the next we have is potassium peroxide, so KO2. So now again here we have potassium that is +1. So this means that on two oxygens we have a -1 oxidation state, or per oxygen it will be a -half oxidation state. So this is how you can identify the 3 types of ion: the oxide, the peroxide and the superoxide. So if we are going to do that now in case of the question that is asked, so we will be having MgO -2 oxidation state for oxygen. Similarly in calcium oxide it is -2 oxidation state. In Li2O it is again lithium oxide, oxygen is -2 oxidation state, and here it is going to be barium peroxide. Okay, so barium is going to be +2, and here we will be having 2 oxygen -2 charge on 1 oxygen -1. Okay, so I hope now this is clear that the correct answer, the peroxide ion, is going to be present in D. Okay. So please be very careful in reading each and every concept related to hydrogen peroxide. That is going to be very important. So next question we come up to is H2O2. This acts as an oxidizing agent in neutral medium. It acts as an oxidizing agent in acidic, alkaline medium, both acidic and alkaline. So this should be a very simple question for you people. But I just wanted to cover up the concept that you people remember. The correct option over here is going to be T choice, that H2O2 is going to act as an oxidizing agent in both acidic as well as alkaline medium. In fact, even in neutral conditions, it is going to act as an oxidizing agent. And also it will be acting as a reducing agent in both acidic as well as alkaline medium, even in the neutral conditions. Okay. Moving on to question number 15, in which reaction H2O2 acts neither as an oxidizing or a reducing agent? PbS plus H2O2, sulfite ion plus H2O2, PbO2 plus H2O2, and Na2CO3 plus H2O2. So for this, obviously you have to learn the reactions of hydrogen peroxide, and not only the reactions which are given in the chapter hydrogen, but there are so many reactions of hydrogen peroxide even in the other chapters of inorganic chemistry. So you will have to compile all of them and learn all of them. We have already done a detailed discussion on hydrogen peroxide in 3 lectures, that is lecture number 11, 12 and 13 in our detailed playlist. So you can watch that lectures also. Okay. So first of all, choose your answer and then I'll be telling you the solution, obviously. So the correct answer to the question is going to be D choice. We have Na2CO3 and H2O2 reacting to form Na2O2 plus water and carbon dioxide. So here there is going to be no change in oxidation state of any of the elements. Therefore, hydrogen peroxide will be neither acting as an oxidizing agent or a reducing agent. Well, in the other threes, it is going to be acting as one. So let us quickly check those reactions as well. So first reaction which was asked in the question was PbS plus H2O2. So PbS plus H2O2 will be forming lead sulfate and water. Okay. So here first of all what you have to understand is what is going to be the change that is taking place over here. So we have lead sulfide, sulfur in -2 oxidation state. Okay, and in lead sulfate it is going to be +6 oxidation state for sulfur. So this is an increase in oxidation state, so this means an oxidation is taking place. Okay, and H2O2, if you are going to check, oxygen is in -1 oxidation state. Here it is going to be in -2 oxidation state, so H2O2 is getting reduced. Fine. So this is a reduction taking place, and therefore oxidation is being caused by H2O2. So H2O2 will be acting as an oxidizing agent, and PbS you can say it will be acting as a reducing agent. So these concepts should be first of all very clear to you people. Okay, now this reaction is very important in itself. What is importance about is its application in everyday life. And what is its application? Well, the lead paintings, they are having a white color of lead. But because of the presence of H2S in atmosphere, H2S reacts with Pb to form PbS and along with that hydrogen. And this PbS is black in color. So the lead paintings, they become black after some time on exposure to air. Okay, but when we want to restore the white color of the lead paintings, what we do is we dip them in a dilute solution of H2O2, which oxidizes PbS to PbSO4 according to this reaction. Okay, so that is why how we restore the white color of the lead paintings which have become blackened after some time. Right, so this is an important application I wanted to share with you. And then we have the sulfite ions and H2O2. So sulfite ions, they will be oxidized to the sulfate ions, right? So here sulfur is going to be in +4 oxidation state. Here sulfur is going to be in the +6 oxidation state. Again, H2O2 will be forming water. So it will be getting reduced and it will be acting as an oxidizing agent. Next, we have PbO2 plus H2O2. So in this reaction, PbO, water and oxygen will be formed. So here again, if you are going to check what is going to be happening in this case, we will be having lead as this is going to be -4. So here lead is going to be +4 oxidation state. Here lead is in +2 oxidation state. So here it is a reduction that is taking place, and the reduction is being caused by H2O2. So it means that the oxidation is taking place. Okay. That is going to be taking place. So here it was -1. Here it is 0. Right. So this is oxidation taking place. So here H2O2 will be acting as a reducing agent. So this concept should be very clear. Okay. Next is question number 16. What is the product of reaction between H2O2 and Cl2? So choose your option. The correct answer to this question is going to be B choice. HCl and oxygen is going to be formed in this reaction. Now question number 17. Hydrogen peroxide oxidizes thiosulphate ion into SO3 2 negative, SO4 2 negative, S4O6 2 negative, or sulfur. So you have to again choose your option, and please, I hope you are understanding that all the reactions for hydrogen peroxide, they are going to be very, very important. Okay, so the correct option over here is going to be B choice, and here it is going to be thiosulphate will be getting converted into the sulfate ions. Even if you forget the reaction, just remember over here sulfur is going to be in +2 oxidation state, and it is going to be oxidized, so it will be going into its highest oxidation state, that is +6, which is going to be there in the sulfate ion. Okay. So the next question we have is bleaching action of H2O2. This is due to its oxidizing nature, reducing nature, the acidic nature, or the thermal instability. So again, the bleaching action of H2O2 is very important, and also along other uses of hydrogen peroxide, they will also be very important. So do give it a reading. Do not miss anything from hydrogen peroxide. That is my sincere advice to you people. Okay, so the correct option over here is going to be D choice. Do remember that hydrogen peroxide, this is thermally unstable. Pure H2O2 is unstable. It decomposes into water and oxygen even when it is going to be heated or on long standing also. Okay, so if you keep it for long, it is going to decompose into water and oxygen, and essentially it is not oxygen, it is a nascent oxygen which is going to be released, and this nascent oxygen is going to be attacking the coloring material and converting it into the colorless material. So this is going to be what? The bleaching action of hydrogen peroxide. So second last question for today, which of the following statement is incorrect for hydrogen peroxide? It is stored in plastic bottles in dark. It acts as an oxidizing as well as a reducing agent. It is used as a bleaching agent. It has acidic as well as basic properties. So the correct option to this question is going to be D choice. Now why D choice? Let us look at all the choices one by one. The best way to practice is going to be when all the choices are given, you should understand each and every choice, because that helps you understand the concept better. Okay, so first choice is it is stored in plastic bottles in dark. So why is it stored in plastic bottles? Why is it stored in dark? These are two things you learn from this one statement. So we've just now talked about that hydrogen peroxide is thermally unstable, right? So it is thermally unstable. This means that even sunlight is going to have some energy, which is heat energy, right? So that can cause the decomposition of hydrogen peroxide. That is why we store it in dark. Why do we store it in plastic bottles? Because one of the things which can catalyze the decomposition of hydrogen peroxide is going to be a rough surface, and generally the glass bottles that we have, they have rough surface. So if we have to use a glass bottle, we generally backline the glass bottles, otherwise we store it in plastic bottles. And here is a list of the decomposition catalysts for hydrogen peroxide. Finely divided platinum can cause the decomposition of hydrogen peroxide, MnO2, carbon particles, dust particles, light, alkalis, and rough surface. Okay, so these are the things which can catalyze the decomposition, and we should avoid the presence of these. Okay, next we have is oxidizing as well as reducing agent. So we've already done a few questions related to the oxidizing and reducing properties of hydrogen peroxide. So this is clear. We've already seen that hydrogen peroxide can act as a bleaching agent. So this is also going to be correct. So the only incorrect option is going to be acidic as well as basic properties. So here please do remember that anhydrous H2O2 H2O2 is going to be weakly acidic. It can react with bases to form salts. For example, NaOH, when this will be reacting with H2O2, this will be forming sodium peroxide and along with that water. Similarly, you have already seen one reaction of sodium carbonate with H2O2. So that is also forming sodium peroxide along with that water and carbon dioxide and Na2CO3. This is also a basic salt. Okay, so Na2CO3 is made up of NaOH and H2CO3. NaOH is a strong base and H2CO3 is a weak base, a weak acid. So the salt formed by a strong base and a weak acid is going to be basic in nature. Okay, so do remember this, that these two reactions, they show that hydrogen peroxide is going to be weakly acidic. So question number 20, our last question for today and a very important question. The volume strength of 1.5 normal H2O2 is going to be given molar volume of hydrogen peroxide at STP is 22.4 liters. So again, volume strength of hydrogen peroxide is very, very important. So let us quickly revise that. So what is our volume strength of hydrogen peroxide? It is going to be the volume of oxygen liberated at STP by the decomposition of one volume of that sample of hydrogen peroxide. So what does this mean? For example, we have 25 volume of H2O2 given to us. So this means that one volume of H2O2 solution will give us 25 volume of oxygen gas at STP. Okay, so if you look at the decomposition reaction for hydrogen peroxide 2 moles will be giving us 1 mole of oxygen and 2 moles of water. Okay, but if I say it is 25 volume H2O2, this means that if I take 1 liter of hydrogen peroxide solution, it will be giving me 25 liters of oxygen gas at STP. Okay, if I say it is going to be 1 ml, it will be 25 ml. Okay, and there are certain relations that we have derived for the volume strength getting converted first of all into percentage strength. So percentage strength, if you have to find out and volume strength is given to you, well, it is going to be 17 by 56 into volume strength. If you have to find out molarity, molarity is going to be volume strength divided by 11.2, and if you have to find out normality, normality is going to be volume strength by 5.6. How we have derived these, I have done the complete derivation for all of them in my playlist again. I hope you are not getting bored, but well, I have done all those things in my detailed lectures. So that is, I think, lecture number 12. Lecture number 11, 12 and 13, they are all for hydrogen peroxide. And there I have done many questions related to the volume strength of hydrogen peroxide. So if you want to have a look, please do have a look from those lectures. So what is going to be the solution to our question now? So volume strength of 1.5 normal hydrogen. So normality is given to us and we have to find out the volume strength. So this should be very easy for us. So the correct answer is going to be 8.40. So how we did do it? Volume strength of hydrogen peroxide is going to be equal to 5.6 into normality. Okay, so volume strength will be 5.6 into 1.5, 8.4 volume. Okay, so this is going to be the correct answer. So that would be all for this lecture. I hope you have gained a lot from this quick lecture of ours, and the detailed lecture is already available, so you can watch those. And also for your information, we also have one more course on hydrogen, and that is we have made a lecture called as Crash Course Hydrogen, where we have put around 75 MCQs from hydrogen, and they are from the NCERT exemplar book, from the previous year JEE mains, advanced NEET questions, and even some state competitive examination questions like Kerala entrance examination, West Bengal entrance examination. So that is going to be a compilation of 70 to 75 MCQs, again revising all the concepts but in a greater detail than we did today. So you can even watch that also. You can watch my complete course also. But please do your exam very well. That is only our motto. So I hope you are going to enjoy your learning with us. You are going to be looking forward to the upcoming lectures. So please do subscribe to the channel and click on the bell icon so that you get a notification the moment we put up the next lecture for you. We are building up this complete series for the mock test of NTA. So I hope you will really gain a quick revision with this and do really well in your examination. So wishing you all the very best. See you again. Have a nice day.